Yeah, okay, so I'm gonna invite the first presenter, Gabriel Dancereo. Sorry. Thank you.
So hi everyone, my name is Gabriel Dancereo. I'm a PhD candidate at Université de Montréal in Quebec, Canada. And today in my presentation, I'll be focusing on the question that we have over here. That is, can we use species interaction networks and their information for biodiversity conservation and management? And so to start off, on a few reasons of why we should want to use species interaction networks. Maybe first, what I mean by species interaction networks, I mean the networks that are formed when we consider the links and the relationships between species and how they're all interconnected. So these links could be either trophic links, as we have in food webs, but they could also be pollination and parasitism. And so species interactions have been shown to be really useful and have in various ways that could guide conservation. And for instance, I've highlighted a few reasons over here. Species interactions help ensuring long-term population persistence and maintaining ecosystem services. They can also help us anticipate and minimize risks of species extinctions. If we think, for instance, of the case when we have an invasive species coming to a community, well, species interactions can help us anticipate and see these potential effects. And yet, despite these benefits that we see, well, network information is quite rarely quantitatively used for biodiversity conservation. And so in a recent manuscript, some co-authors of mine and I looked at these questions and wanted to highlight a few challenges that have for now impeded the use of network information for biodiversity conservation. But we instead want to highlight that instead of seeing those as challenges, we should see that we have opportunities to make use of information that is available right now and that could guide conservation action. I will highlight these two challenges that we presented in the manuscript. So the first would be something that we've heard ourselves working on networks, is that there might be a lot of uncertainty regarding network composition, meaning what networks are made of in one particular location across space, or also in the responses that networks could have to disturbance. When we think of extreme climate events, highlighted forest fires and drought, or could be again the case of invasive species coming to an ecosystem, there is some uncertainty in how network will change based on those. And what we, instead of seeing those as a challenge, once again, we want to highlight that, well, yes, these uncertainties exist, but we actually have sufficient scientific evidence and tool to overcome these uncertainties and make use of the information that we have for conservation. And for instance, for the first challenge that I highlighted, the one of network composition and its uncertainty, well, there's been a lot of work recently documenting meta-webs that can be a relevant starting point. Meta-webs are, for a given region or species pool, the set of potential interactions between the species. I've highlighted Canada here, where I'm from. That's because I've worked before with the case of a meta-web for Canadian mammals, but there's various other ones documented in the world. There's one in Europe for all tetrapods. There's also many ones in marine systems and freshwater systems. And those are really relevant starting points from which we can derive predictions of network structure and composition in space that can help us guide conservation planning while we keep gathering more empirical data. And the second part of this uncertainty concern that we had was regarding the responses of networks to potential changes. And again, here there's something that we can do, as we can already simulate many realistic scenarios of change that can help us delimit the potential changes in network structure. And this can help us guide some actions, as for instance, we can highlight some areas that are maybe at risk of changing more than others and where actions might be more needed. This can also help us identify areas that are very uncertain and where we require even more data. And so despite these uncertainty as it's perceived here, there are already things and tools that we can use to get a head start and start using this information all over on networks. The second challenge that we highlighted here is something that we've heard ourselves as academics working on networks and information, is that there is sometimes a perceived lack of interpretability and relevance of some network metrics for practitioners that have impeded their use in decision making. Well, to answer that, the point that we want to make is simple, but it's that, well, it's not necessarily all network metrics that will make relevant indicators. When I talk about network metrics, I mean the measurements that we can make on a network regarding its structure and composition. So we can think of metrics such as connectance, nestedness, proportion of motives. There's various ones in network literature. But the ones that will make good indicators that could be useful for conservation will require two things. So first, to be clearly tied to conservation goals. For instance, one measure needs to help us maintaining ecosystem resilience. And the second thing that is very useful is that to facilitate uptake of these network indicators, we need to do a good job at communicating how they meet common and important decision-making criteria. For instance, you see here the RORS criteria, but there's also like the SMART, and there's many other ones that are commonly used in decision-making. And we need to think of this as a form of a grid, as we see here, that we need to fill and clearly communicate how our indicator is meeting all of those elements. And so I will highlight an example of this using one example of potential indicator, that is network robustness. This is a measure of the capacity of a network to withstand species extinctions following a disturbance. To highlight a quick example, think of if you had a network in one location across space where you had some basal consumers, some herbivore species, and you had secondary consumers as well, the predators. This measure of network robustness will try to quantify what happens when we have a disturbance and what happens with the species that are affected by this disturbance. It could be either on the same network with possible sets of disturbances or at different locations across space. And for instance, if our species are higher above in the networks over here that become primarily extinct, well, there is not necessarily any other higher level species that depend on those, and this does not necessarily lead to secondary extinctions. Whereas it's lower level species in the networks that are targeted, some predators might depend on them, and there will be further repercussions on the network and more secondary extinctions. So species becoming extinct because they've lost their prey in a system. And so the second network on the bottom over here would be least robust than the previous one. And so to highlight how we can evaluate this measure along the RORS criteria, I'm going to give an example here. This is a quick example, but you have the manuscript that we have over here in which we do the detailed description over that. And so first, could we say, is it a relevant metric? Well, clearly, robustness aims to assess and prevent species extinction. It's at the heart of this measure and again of conservation action, so we can definitely say it's a relevant one. It is objective because it's based on quantitative assessments of pre- and post-disturbance assessments. It's a measure, something we can calculate. It's also available because it's compatible with available metawebs and local monitoring data that already exists. And it's also realistic because of those reasons, because there are already monitoring programs that can help us and feed information for this one, and the overall methodology is not overly complex. And finally, an important one, it is a specific measure because it has a very clear interpretation, being scaled from 0 to 1, where 1 would be a network that is fully robust, where there are no secondary extinctions, and 0 would be the case where all secondary consumers become extinct. And so here, I hope with this example to have highlighted how we can detail how one measure really meets each of those criteria over there. And again, with the time that I have left over here, I want to highlight the case of how we can use robustness and apply it to evaluate the effects of extreme disturbance scenarios. So here we see an example of Europe. That is because we use the European tetrapod metaweb to compare two extreme scenarios. Briefly, what we did is we built SDMs for all tetrapod species in Europe and used the metaweb to evaluate the consequences given these disturbance scenarios. The one that we see on the left would be a worst-case climate change of RCP 8.5. And the one on the right would be failure to protect all endangered species. For this, we use the IUCN threat status and consider that in this scenario, we would fail to protect all species with a status of vulnerable or worse. And so, with this measure of robustness, we can already start to have some information about what networks would be like over space. And we could see, for instance, that most networks are robust across Europe, except in some specific locations, mostly in northern Scandinavia and in Russia, in the tundra ecosystems. We see also the example of Crete and the Canary Islands, and those, with this measure, we're able to identify some areas that might be more of concern and where there should be targeted action, trying to identify which species are more vulnerable and potentially implement some conservation action into those. And so finally, to wrap up, this question that I had of can we use network information for biodiversity conservation and management? Well, my point is that yes, we can. There's existing data and methodology that are already available and sufficient to generate usable information that could be important. But that to do so, network indicators will need to meet important decision-making criteria and specific conservation goal. This is the key to facilitate their uptake. And finally, that it's really important that we start using this information right now while we keep building empirical and monitoring programs that can feed on better data to keep improving our predictions and the actions that we take. Thank you.
Thank you, Gabriel. Time for one question, maybe? No? Okay. Gabriel, thank you very much. He's going to be here for discussion afterwards. So next speaker, it's Deborah Drucker from Embrapa, Brazil.
Hello, good afternoon. I'm honored to be here today to present this work. It was a result of a collaborative effort from many organizations and people involved. And we worked with machine actionable metadata to fair assessments in plant pollinator data sets. So to bring a little bit of context, this work was developed during the World Fair project. It was funded by the European Union, led by CODATA and the Research Data Alliance, focused on the implementation of the FAIR principles in many different disciplines and also in disciplinary research. I did have a slide for fairness, but I think most people already know that it stands for findable, accessible, interoperable, and reusable. Many of the talks here during the Living Data conference have talked about it, so I think we can move forward. So in the World Fair project, we had 12 case studies, and this work I'm presenting today is related to the agricultural biodiversity case study. We also worked with plant-pollinator interactions, so I'm glad that Gabriel already presented before me the importance of pollinators for conservation and also for food production. And our case study was also related to the one led by GBIF, which was the biodiversity case study, and we interact during the World Fair project. So we worked with 6, I'm sorry about the numbering here, it should be 1, 2, 3, 4, 6, so 6 pilot studies from different organizations. So we had the study from Argentina in the Pampean region. We also had the work from the Brazilian plant pollinator interactions network, the work the Kenyan researcher on agriculture, the Kauro, worked with African pollination as well. We also have the USDA from the United States as a case study. HiveTrax, which is a startup that works with beekeepers in several regions around the world. And also a case here from Colombia, from the University of SES in Medellin, together with the CIP Colombia folks. So we work with this data from those case studies, and so I presented last TED Week a more broad overview of our work, but today we're talking on a specific part of the work that was the machine actable metadata. So with the profusion of the large language models, it's becoming more and more important to have the machine actable metadata. But still in biodiversity data, it's not so common to have these semantic artifacts and other enablers of machine actionability. So that's why we decided to work with that. With the 6 case studies I mentioned, we perform a standardization strategy based on the work led by José Salim, who is here with us also today. And we work with Darwin Core and EML, the ecological metadata language, and also the plant pollinator interactions vocabulary, together with the Global Biotic Interactions platform, the GLOBI, which is an aggregator of interactions, species interactions data. So just a glimpse on the plant pollinator interactions vocabulary. So we developed that with the Brazilian network of plant pollinator research. And it's very important to document the details of the vocabulary, of the interaction. So we have 48 terms right now. Maybe it's already more than that because it's a living effort, but it's divided in animal, plant, flower, interaction, reproductive success, and nectar dynamic classes. So if you are interested in more details about that, we have more resources, and we would love to talk about it. So together with the semantic artifacts, we also work with GLOBI, which is this platform that integrates data providers, users, the communities of standards, and also the data mobilizers that we call. And GLOBI already had this workflow with 2 tools, the bots that we call, Normer and Elton. And together with the World Fair project, we improved this workflow. So using Normer for the data set, the name and alignment, and the Elton for the interaction, information about the interaction. So to get with this, using EML and Darwin Core and PPI, we were able to extract the metadata by these robots and perform these review reports, which based on the metadata, they the reports already point for data quality. So it's possible to access the fitness for use of the data set, and there are also points for corrections, maybe with some typos in the species names or things like that, and also some summary statistics of the data. Even if the data is not available, if the metadata is available, it's already possible to extract some summary. And all this data is available, at least the metadata, when the data is not available for some property reason or sensitiveness or things like that. But here in this dedicated page in the Globi platform for World Fair, we have all the cases that I mentioned. The data is here. And if we click on the R, the review report is generated automatically according to the version of the data that is available there. To conclude, we have some insights that this kind of automatic reviews allow the user to see if the data is fit for the purpose that the person wants to use, and it's less time fixing errors like name typos and things like that, and it's possible to make questions like what is the more frequent interaction type, or also comparing different data set taxonomic ranges. So we can use the human ability for really thinking about why the data can be used and how it can be used, and not so much we're dedicating time to data wrangling and things that machine can do for us. So I conclude here. I'll just point to our materials. So if you are a data set producer in the plant pollinator, we have this material to standardize the data. And also in the report from the World Fair project, the review reports are presented in more detail. So I'd like to thank you all very much for your attention, and our partners and funders. As you can see, there are many people involved, and it was a great collaborative effort that we had. Thank you very much.
Thank you very much, Deborah. One question? Does anybody have a question, comment? What? Oh, there's any question online? ¿Hay alguna pregunta online tampoco? Chat, Zoom. Okay, so thank you, Deborah. Our next speaker is Maite Tellechea from Spain. She's going to talk about Hold the Data, a call to prevent biodiversity, knowledge from falling into darkness. Creo que sí.
Sorry. So, hi everyone. Thanks for joining. I'm Maite Tellechea from the University of Navarra in Spain, and this is a call to prevent biodiversity data from falling into darkness. As we all know, conserving biodiversity means studying the status and distribution of populations, establishing protected areas, reducing pressures on ecosystems, but it also means complying with legal obligations and international commitments. In the European Union, the Habitats Directive is the key legal instrument for nature conservation. It requires member states to protect targeted habitats and species and to report every 6 years on the conservation status through sexennial reports. Those reports include data on population trends, pressures, and what we will focus on today, distribution areas. Some sexennial reports must rely on the best available evidence enabled by efficient biodiversity data management. Efficient data management helps us turn data into what we call digitally accessible knowledge, data that have been digitized, standardized, and published in a way that makes them findable, accessible, interoperable, and reusable, in line with the well-known FAIR principles. When this doesn't happen, we end up with dark data, existing data that are difficult for potential users to discover or access, making them more likely to remain underused and over time to be lost. Unlike dark data, DAC can be efficiently integrated into reporting, monitoring, research, or policy-making processes. Any data remains dark until published. The delay between data collection and its publication is known as publication lag and should be minimized as much as possible. Using bats as a case study, we will look at the challenges of poor biodiversity data management. Much biodiversity data becomes dark, remaining unpublished or facing long publication lags. Data publication doesn't guarantee integration and may remain data underused. And we can add here one more point, because as Alice said the first section, many species assessments are based on private data. So we will try to answer these key questions. What was the publication lag of a sample of existing bat data during the 2013-2018 reporting period? And how much could dark data and DAC have contributed to the distribution areas of bat species published in that most recent sexennial report? So we focused on the 31 bat species that are targeted by Habitats Directive and are present in Spain. We relied on two main data sources: the official distribution area of all bat species published in the most recent sexennial report, and almost 24,000 GBIF occurrence records, with event dates between 2013 and 2018. We estimated the publication lag of GBIF records by comparing their event date and publication date. Using the publication date, we then categorized those records into two groups: dark data, records published after 2018, and DAC, records published before 2018. We calculated the distribution areas for each bat species under 4 different scenarios: the official reported distribution area, including dark data, including DAC, and all data integrated. We did it in QGIS using the temporal 10 kilometers European grid. And we calculated the distribution or the contribution of dark data and DAC by measuring with the percentage of increase in the distribution area resulting from their inclusion. So one of the most important tasks was to determine both the event date and publication date with certainty, especially the publication date, as GBIF records do not have a specific field indicating it. But we finally worked with this number of records, not bad, for which both dates were known with certainty. The bad data were published with an average 4-year lag. But there's an evident and quite suspicious, linear trend here. Something clearly happened in 2020. More than 20,000 of all our records were published that year and by a single user, Murciélagos de Cantabria. This creates a significant bias in our analysis. So at this point, we can estimate the publication lag, excluding those records, and see what happens. and the publication lag rises to almost 5 years. We had over 23,000 dark data existing and not available for the sexennial report, and only about 600 dark records published and available for the sexennial report. We had two highly unbalanced data sets, something we need to keep in mind. But what about their contribution to the reported distribution areas of bats? We found that 90% of distribution areas increased when dark data were incorporated, and 74% of areas increased when DAC was included. There were more dark data and they contributed more. The probability of contribution was 22% for dark data records and 13% for dark records. This table summarizes the results for each bat species. These three bats seem to have benefited the most from the integration of dark data and dark records. Most species benefited from their integration, except for these two bat species. As we look across all the distribution maps, we can see that in most cases, the bulk of the contribution comes from Murciélagos de Cantabria. Okay. We also notice that some regions consistently lack data. Lack of sampling, unavailable data, we don't know yet. But there's something clear. Distribution areas were more accurate when dark data were incorporated, and to a lesser extent when DAC was included. So to conclude, the GBIF dark data, the GBIF bad data they generated during the 2013-2018 reporting period were published with an average 4 or 5 years lag, hindering their integration. Efficient data management, including timely publication and use of available information, is essential for biodiversity reporting. We have seen that the integration of existing but missed data into reporting would have rendered more accurate distribution areas for 29 out of 31 bat species. And to conclude, establishing procedures for conservation policies that minimize data latency and retrieve data can help us more accurately assess the conservation status of a species and improve decision-making. Ultimately contributing to better biodiversity governance. Thank you very much.
Thank you, Maite. Any comments, questions? No? Thank you, Maite.
Thank you.
Okay, so our next speaker is Rodrigo. Wait, it's Rodrigo or? Yeah? Yeah, it's Rodrigo from IBAMA, Brazil. Thank you. Yes, sim. Você quer ficar aqui em cima ou aqui embaixo? Aqui embaixo. Ah, é?
Perfeito. E aquela paradinha?
A paradinha está lá em cima.
Okay. Teach me here, please.
Não sei qual é.
O verde? Tá, ok. Hi, everyone. My name is Rodrigo Koblitz. I'm from IBAMA, and I will present to you the CISBIA, the Biodiversity Data Management System for Environment Impact Project Assessment. The CISBIA is a database was constructed in partnership with ICMBio, and ICMBio is an institution of protected areas in our country. And our work is giving the license and deal with the license process in Brazil. And we have a lot of different types of companies doing that. Oil extraction, hydroelectric dams, mining, etc. And these guys are the very important sponsors of the field studies over there. Now we have 3,693 licensing process in Brazil, and most part of them invest some money, spend some money in field research. And we have a problem with this data because all of this data we go into PDF and we lost this information. So we tried to figure out how we can keep this information in one place. And we try answer these questions that stay here before we resolve our problem. We think that if we can answer the questions about the where, when, how, and who was get in the sampling, we can get a good describe about what's happening in the field. So the problem with where is that we can't get this information like a point, but we can get this information like a plot. And if you have a plot, we can get a better information because it can go directly for something like density, measures of density. When we have a point, like a local of the sampling, we need to use another information called field of view and use some distribution. So the questions here is, if the consultant go to the field and get this information like a dot, like a point, we get this data like a point. But if we use a plot, we prefer get this information like a plot. So we need to construct the system to get this information like these people go into the field and make your sampling. And another issue is about the where. When the people make some transact to get information, and we lost a lot of information when we get just the initial and the point of this sampling. So we try to get the exact path of this consultant or researcher make in the field. In this case here, in the situation of the absence of this species, if you know that was the track that the consultant done, we can make some suppositions, infer about the border effects, for example. But if you don't have this information, you have just the initial and the end point, we don't speculate about it because we can't figure it out that is a straight line and that not border effect. We just makes your sampling in the deforested area. And the way for we get this information is from the vector file, and in the SysBia we ask for upload the shape file for characterize where you go in and make your sampling. The problem about when is that we have a lot of different attributes to characterize this information. In the MISNET methodology, for example, you take your initial and final hour as essential information for you try to understand who was there. So this is important information for that methodology. But for get tree information, the initial and final hour, or even any information about the hour have any relevance at all. We just have a data, and it's more than enough. Another type of methodology, like a camera trap, we need another types of pass this information for the IBAMA. So you need the initial and the final data and the initial and the final hour. The another issue that we can deal is how was your process sampling. So if you have some sampling of mist net, for example, with one net, or if you have with 6 net, we have a completely different information. You will get a different group of species and a number of the individuals, and you need to know what was your effort on that, because this is could you infer about what the area is more important, for example. And we need record the settings of your equipment too, and beyond that we need record the physical conditions of your sampling, because all of this information is extremely related with who you get in the field or not. So that's part, the how we can think that like a physical environment condition or a field method equipment. Both this information was into this issue, how. And all of this, you take all that information, and now we will see who we get. It's not just a question about the name of the species, but the condition of these individuals. If he is in the rehab situation, if it is dead, or if he is a collective group of the individuals, and we need to take some measure like a total of kilograms, or a percentage of the oil that cover the body of the individuals. All this information is close to the who questions. So in SysBia, we create the 2 different worksheets. One of them is effort worksheets and get all this information about the sampling, and another worksheet, it's a biodiversity that get all that information about who. We understand that some information are about where, when, and how is related directly for individuals. So when you make some sampling of transect and you run on the 5 kilometers transect, we get the initial physical conditions, final physical conditions, but eventually when you get the individual in some point, you need to take this measure about the where we get specific this guy, this individual, when this happening in the time, and what are you using to see it. Our goals is get some information like that. That's a naive map, but give you some idea what we're looking for. Here we have detailed information about the effort, where you go to looking for someone. And right map, you have the information of where you found this someone. And this information for us is essential because we license process. So we try to figure out what place we can be destroyed, but put a dam, mining, or a hydroelectric. So the information where we don't found biodiversity is almost so important, like the place where you find some biodiversity. How I say that's a naive situation, you need to put some layers over there, and conservation planning, systematic conservation planning is one of the tools that we use to help us to think about these issues. So in this way, we have our relationship in our data set, in the spreadsheet, and code it's a Unity sampling code that you upload in a shapefile, and you take this information in worksheet of effort, and the IDPROV, provisory identifier, you make this relationship with the biodiversity worksheet. So this is the heart of the SysBia. We have crossed a lot of steps up to stay here. But here where we can elaborate our effort and biodiversity worksheet. So the user can put some information, can remove some information. Like here, we put in the rainfall. We don't have this information in the worksheet yet, so the user choice this attribute and selected. Now we have 567 attributes for free choice for effort and 549 attributes for a free choice in the biodiversity worksheet. So, if you need have some attribute that we not mapped yet, we can't create this. We just put this here and make this relationship with Darwin Core. And we have a problem here because we can't, you make an option to not use the completely Darwin Core protocol because we need have some specify some attributes like wind core that be a little misleading for users. So we take advantage of our mandatory situation. We set that wingspan is one thing, wind chord is another thing, flattened wing land is another thing, and we put this for the user. That's the final work. We have some validation for the researcher going down, get this worksheet, fill, upload, we have this automatic validation, and then we can search for your data and from in the system or by API, and you can use it. Thank you very much.
Thank you, Rodrigo. Does anybody have any comment or question? Okay.
Thank you, Rodrigo. I can imagine it's a really huge effort, all this work. And I have actually two questions. One is how difficult it is to have the users entering the data in the correct way, and how do you do to correct it if it's not correct? And if any of this can be made available through CBBR and GBIF, or if it's all sensitive information.
All of this data have a public license, so everyone can go there and get and use this data, publish and etc. This is this does have the automatic validation. So if you put the correct name of the species, put your information in geographical in correct ways, that we have some ways to validate that. And this upload that was done, that was information that we have, and everyone can see that. These information are have one CNPJ, one company that's responsible for that, and any problem with this data, that company can need answer for it.
Thank you. So we want to watch a presentation now, a video. Yeah. So this presentation is from Leonardo Lima. He's a researcher from the Brazilian Institute of Geography and Statistics. This institute, its mission is to provide an updated view of the country to inform public policies, civil society, and the private sector. So now this institute is now also doing some assessments in biodiversity data for public policy, like the environmental economic accounting for Brazil. So, yeah. I'm not sure if Leo's online. I hope so, but...
My name is Leonardo Bernamini, and today I will present the main results of our work, assessment of Brazilian biodiversity data, that was developed by the Brazilian Institute of Geography and Statistics, IBGE, in partnership with the Brazilian Biodiversity Information System. Brazil is one of the 17 megadiverse countries in the world, which means we hold an enormous responsibility for our natural heritage. Biodiversity is not only a national asset, but also a global one. Biodiversity's benefits, threats, and impacts are shared globally, which makes international cooperation essential. Brazil is a signatory to key agreements like the CBD and the SDGs, whose targets must be effectively monitored. The biodiversity data are vital for metrics, indicators, and the monitor of all these goals. In this context, the BGE launched the first Brazilian biodiversity data assessment in 2023. At the global level, biodiversity data are made available through initiatives such as GBIF, the Global Biodiversity Information Facility. In Brazil, the national node of GBIF is SEBBR, the Brazilian Biodiversity Information System, a platform that integrates data and information from different sources. Even though a large number of records are available online today, many of them are incomplete. Sometimes, the exact location, the taxonomic identification, the collection date is missing. In other cases, the information exists, but it was not shared in full. On top of that, we face sampling gaps, regions where surveys simply do not exist, and also biases towards some groups and some locations. These temporal, taxonomic, and spatial gaps, together with known biases in biodiversity data, are challenges for the user. In this work, our objectives were to evaluate the quality and coverage of species occurrence records in Brazil, comparing patterns across major taxonomic groups, and identify knowledge gaps and research priorities. We also aimed to highlight key data limitations to support strategies for improving and expanding biodiversity information. We started with more than 22 million records downloaded from SBBR that were published up to December 2022. We first screened them to select valid records and then analyzed their completeness in 4 dimensions: taxonomic, spatial, temporal, and redundancy, meaning records that by the nature of collection share the same location, date, and species. We then classified the records into levels of completeness to carry out some analysis regarding their data quality. From these records, we selected valid present records occurring within Brazilian territory, both marine and terrestrial, and run a series of checks to assess their completeness. We then evaluated the completeness along 4 dimensions that I have already mentioned. And to handle the multiple combinations that this completeness criteria might be present in some records, we classified those records into 3 levels of completeness. Level 1 included the most complete records with valid geographic coordinates, collection date, and identification, at least at the species level. They are suitable for more precise analysis. Level 2 included records identified at least at the genus level or with less precise location. This kind of records many times can be complemented to produce more precise records. And the remaining ones were grouped in level 3 as they lacked those critical information. Finally, we specialized the level 1 records to visualize the distribution across Brazil and used them to compute some metrics regarding data quality and coverage. Now for the results, this first table shows the origin and amount of data across taxonomic groups. In this study, data publishers were classified into 4 categories according to their characteristics. Citizen science are records that are published by a community of users. Biological collections that are repositories of organisms or samples stored and organized for scientific purposes. Research projects or programs that are results from scientific studies and monitoring projects, and others which do not fit into the previous categories. You can see that the number of records between the groups is largely variable, and also the main source for this data across groups. Birds and plants account for the largest number of records, while mammals have the fewest. The main limitation observed was the absence of geographical coordinates. The second one was the lack of species-level identification, but incomplete records can be supplemented and utilized in the future. Arthropods and fungi had more problems with taxonomy, with many records lacking identification to the species level, while the other groups had more problems related to the absence of geographic coordinates. Next, we looked at the temporal trends of the mean number of records per year, the red line, and the share of records at the level 1 of completeness, the blue line. For almost all groups, we see an increase in both quantity and quality in recent years. Most groups also show a drop in the most recent years, reflecting the natural delay between data collection and sharing. Birds are the exception because most records come from citizen science initiatives, which are shared more quickly. But on the other hand, they have a greater percentage of redundant records with multiple observations of the same species at the same time in the same location. Looking at the percentage of records in each of the defined levels, we see that, except for birds, the share of complete records does not exceed 30% of the total available for any group. We also mapped level 1 records across the IBGE statistical grid using 50 by 50 and 25 by 25 kilometer cells across the terrestrial and marine territory. This allowed us to identify where biodiversity knowledge is more complete or still lacking. Here is an example for the plant records. We can see clearly some regions with more record concentration. We also use this other indicator regarding the age of records. So this data is showing if the majority of the records in each cell is old or recent, and can guide which areas need to be revisited. You can see here many of the areas in the Amazon, for instance, in the northern Brazil, have plant records, many old plant records, so we need them to be revisited. And the third indicator was the sample completeness. That's calculated only for cells that have a certain minimum number of records, and it shows how much of the estimated richness of that area has already been sampled. Even if a cell has many records and they are recent, they might be focused on one specific type of ecosystem or taxonomic group, and the representativeness of the cell biodiversity will be low, resulting in low sample completeness. In general, there's a significant difference in the distribution of biodiversity records between marine and terrestrial cells. And we also observe common points of concentration for various groups, probably because the ease of access and the presence of research infrastructure, highlighting large areas in the country that need increasing the efforts for the biodiversity data production. We found striking differences between terrestrial and marine areas. Marine records are much fewer and more limited, with, for all groups, have over 80% of the cells with no record at all. For the terrestrial cells, while birds and plants have at least one record in around 70 and 90% of the cells respectively, only around 30% of them have a minimum number of records. Finally, we produced a map that integrates data from all nine groups, considering the age and availability of records. And this map can show us where are the common concentration points between groups, and also where are the major gaps that need data for all nine groups. Biodiversity knowledge is limited by incomplete data and uneven sampling across species and regions. While new methods can enhance existing data, prioritizing data production, curation, and sharing is crucial. Strengthening initiatives that organize and publish biodiversity data will improve access and support effective conservation efforts. The second edition of this assessment is underway and is expected to be launched in 2026. Thank you for your attention. The full publication can be found at this QR code. And if you need anything, just contact us at IBG.
Any question online? Oh, comments? Okay, it looks like we need to mobilize more data, marine and terrestrial data in Brazil, and also publish. No? Oh, sorry. So we have another presentation now. It's Kayla from CBR. She's going to talk.
Thank you. Só apertar. Hello, I am Kayla. I am from Brazil, and I work in the Brazilian Biodiversity Information System. I will speak in Spanish, Portuguese, Portuñol, because the translation is not very well. So, since my slides are in English, I think it's better for all. Meu nome é Keila, então vou falar de eu trabalho no sistema de informação sobre a biodiversidade. É uma plataforma nacional. E vou falar sobre a meta 30 por 30 da CDB. Não está passando. Ok. Nós sabemos que esta meta de 30 por 30 temos que conservar 30% da superfície terrestre com vegetação natural até 2030. E eu vou falar pouquinho da situação em Brasil. E nós temos na Amazônia cerca de 80% da área está conservada e 20% já se foi, está desmatada. Destes 80%, nós temos como 42% que são áreas protegidas, que são terras indígenas e outras categorias de conservação, as unidades de conservação em Brasil. Pero fora da Amazônia, nós temos menos que 10% protegido formalmente. Então, nós sabemos também que o Brasil é grande produtor de alimentos e nesses biomas, principalmente Cerrado, existe grande produção de soja, não sei como se fala, soja e gado. E, portanto, estas terras estão praticamente toda ocupada e é quase impossível nós criarmos mais unidades de conservação formal. Então, para que possamos atingir a meta de 30%, temos que contar com as terras de produção, né, as terras privadas. Temos um instrumento em Brasil que se chama, é uma legislação, né, de 2012, que colocou a reserva legal. É um instrumento que muito importante, que diz que fora da Amazônia, os produtores têm que manter pelo menos 20% protegido dentro de sua propriedade. E este sistema os proprietários têm que declarar esta área protegida dentro de sua propriedade. Então, hoje, o Brasil está todo quadriculado com as reservas legais. Este é um exemplo. Os traços em amarillo são as propriedades e os polígonos em verde são as áreas de reserva legal. O problema é que o monitoramento das reservas legais é só feito por imagens de satélite. Nós não sabemos quanto há da biodiversidade, se há espécies exóticas, se há espécies endêmicas, e, portanto, não é possível garantir que esta proteção é efetiva. Então, uma proposta que temos é que os proprietários possam fazer suas próprias avaliações, registrar as espécies que têm nos polígonos de reserva legal, e aí temos uma imagem de uma propriedade com o polígono e os pontos já mapeados das espécies. E o proprietário pode usar, por exemplo, aplicativos como o iNaturalist, e estes dados podem ser trazidos para a plataforma brasileira, o portal espacial. Então, temos como avaliar a riqueza de espécies de uma área de reserva legal. E a ferramenta possibilita que tenhamos um relatório desta área, do polígono de reserva legal, que nos informa quantas espécies existem, se existem espécies ameaçadas, se existem espécies exóticas, etc. Então, estamos propondo a ser estudos de caso. Se alguém tem uma propriedade em Brasil, podem nos procurar. Nós iremos apoiá-los. E, bueno, os benefícios é que podemos ter uma validação ecológica das reservas legais, podemos ter listas de espécies para as propriedades rurais, podemos suportar indicadores da biodiversidade, pagamentos por serviços ambientais, certificações, planejamento de corredores ecológicos e, por fim, podemos ter uma forma de contar com as propriedades privadas para alcançar a meta da CDB 30x30. Muitas graças. Thank you.
Thank you, Kayla. Any comments, questions? Okay. Going there. Pega outro microfone lá para responder. Gracias.
Gracias, Kayla. Para alcanzar la meta del 30x30, además de proporción de superficie, se requiere que sean áreas importantes y manejadas de manera eficazmente. ¿Esto cómo consideran que podría ser a partir de estos esfuerzos? Gracias.
Bueno, podemos ter algumas especificações, mas para a legislação que é uma coisa que está em andamento. Então, pero a ideia da legislação em Brasil é que estas áreas não sejam mexidas, que sejam realmente áreas de vegetação natural. Então, nós pensamos que se podemos saber quantas espécies têm, e se há poucas ou há muitas, ou há poucas com relação, por exemplo, a uma área protegida, a um parque, podemos propor que se plantem mais, e podemos, a partir do conhecimento, podemos proponer adequações.
Otra pregunta, comentario? Ay. Any other comments or questions? No? Okay, thank you, Kayla. Yeah, and our So our next speaker is Alejandra Narváez Vallejo from where? From Colombia. Thank you. En el medio, en el verde. ¿Este? Sí, para pasar. Creo que sí. Sí, moderno. ¿Quieres subir arriba o qué? Yo creo que sí, para no cargar. Entonces sube.
Yes, now. Good afternoon. I'm very pleased to be here, but I am going to present Spanish, so now I'm going to switch the language. And now I have to think that I'm going to switch the language. I'm sorry. Yeah, okay. Bueno, hoy les voy a presentar acerca de un trabajo que tiene que ver con un índice de integridad ecológica de ecosistemas de agua dulce, que se reelaboró con un convenio entre el Instituto Humboldt y The Nature Conservancy. Este proyecto tiene como objetivo evaluar el índice de integridad ecológica en un área piloto para su posterior implementación a nivel nacional, lo cual es muy importante para hacer el seguimiento de las diferentes metas que tiene pues, Colombia como nación a nivel nacional e internacional. Bueno, entonces, ¿qué viene siendo la integridad ecológica? Pues la integridad ecológica es aquella capacidad que tienen los ecosistemas para poder cumplir con sus procesos ecológicos, pero también para mantener la biodiversidad y para mantener lo que tienen que ver los recursos y los servicios ecosistémicos a la sociedad. Y es en este punto donde es muy importante hablar de lo que son los atributos ecológicos clave, que son aquellas características que precisamente permiten el mantenimiento de estas funciones y también de los valores de conservación de los diversos ecosistemas. Entonces, para este trabajo tenemos 5 pasos principales que tienen que ver, pues, primero con definición de esa área piloto, las unidades que se van a analizar, esas características que van a ser consideradas esenciales para el funcionamiento de los ecosistemas y pues el cálculo de integridad. En nuestro caso, entonces, este estudio se hace en la cuenca del Orinoco, en la parte colombiana, que cubre un área de aproximadamente 346.000 kilómetros cuadrados, es al oriente de Colombia. La unidad de análisis vienen siendo microcuencas, son aproximadamente 4.300 en el territorio. Y pues bueno, estos atributos que consideramos esenciales para los procesos que les mencioné, entonces van a ser la calidad del agua, entonces que viene siendo amenazado por todo lo que tiene que ver con vertimentos que están asociados a diversas actividades antrópicas. La estructura física, entonces donde se evalúan los cambios en las coberturas de la tierra, deforestación, incendios forestales. Tenemos la conectividad longitudinal, donde se evalúan aquellas barreras al flujo normal en el cauce del río que limitan o dificultan el flujo normal. Régimen hidrológico, aquí se van a evaluar 2 cosas, que tienen que ver con variabilidad en el clima y con la demanda de agua pues, por parte de las actividades humanas. Y finalmente, la composición biótica, que pues también se va a ver afectada en su equilibrio por la presencia de especies invasoras y especies exóticas. Cada uno de estos características tiene su índice correspondiente, de tal forma que vamos a tener 6 índices asociados y finalmente estos índices pues, se van a integrar en un índice compuesto para calcular la integridad total. Acá digamos que el esquema de trabajo general, vamos a tener una gran cantidad de datos que vienen de fuentes nacionales, son las de puntico verde, y de fuentes internacionales, las otras, que vienen a diferentes resoluciones, tanto temporal como espacial, y pues que requieren un gran manejo y suposiciones, pero muy bien hechas, para su integración a modelos matemáticos e hidrológicos que permiten el cálculo de los diversos índices de integridad para su final composición en el índice de integridad total. Bueno, ahora les voy a presentar cada uno de los índices, entonces en las diapositivas para que lo tengan de referencia siempre va a haber una parte a la derecha o izquierda en la parte superior donde se van a mostrar cuáles son esos fuentes de datos, esos datos importantes que se van a usar para integrar en cada uno de los índices. Entonces, el primero viene siendo el de integridad de la conectividad longitudinal, donde lo que se hace es evaluar, a ver si lo logro, evaluar la longitud del río desde una barrera hasta la desembocadura con relación a la longitud total del río. Entonces, este viene siendo el de integridad por conectividad. Luego tenemos el de integridad por calidad del agua, donde nuevamente pues vamos a tener, vamos a tener varias diferentes fuentes de datos relacionados con agricultura, bueno, actividades agropecuarias, minerías, pozos petrolíferos, todas esas actividades que pueden causar algún efecto en la calidad del agua. Con base a estas actividades, entonces se van a ver cuáles son los efectos en el agua, en esos determinantes de calidad, se hace una ponderación y pues se calcula el índice. Algo similar ocurre con el índice de estructura física, nuevamente se evalúan una serie de factores, incluyendo vías y bueno, las que había mencionado anteriormente, incluyendo también fuegos, y se van a evaluar en la cuenca el impacto de cada uno en cuanto a extensión como en cuanto a presión, o sea, grado de impacto, se evalúan, se hace una ponderación y así se define la integridad de la estructura física. Tenemos la integridad de composición biótica, entonces se evalúan nuevamente presiones humanas relacionadas con vías, población, uso de la tierra, y estas presiones se relacionan, se crea un modelo donde se relacionan las presiones con la presencia de especies exóticas e invasoras según modelos. La relación entre estas dos permite crear un modelo de probabilidad de la presencia de estas especies y así pues también vamos a definir entre mayor probabilidad pues menos es la integridad de la zona con respecto a este factor. Y finalmente, los dos índices que están relacionados con lo que tiene que ver con el régimen hidrológico, entonces el primero es el de demanda hídrica, donde con base a las bases de datos que nos van a dar información sobre la cantidad de agua que usan diferentes actividades, se va a calcular el caudal del río remanente después de que se hace uso del agua para las actividades y se relaciona con el caudal ecológico. ¿Qué me refiero? Pues a ese mínimo caudal que se necesita para que el río cumpla sus funciones ecológicas de forma correcta. Y finalmente, el de variabilidad climática, en el que se hace un análisis de las series de tiempo relacionados con la precipitación y se calculan las anomalías. Todo lo que se considere como más agua de lo normal o menos precipitación de lo normal se considera como un deterioro de la integridad y entonces todo lo que esté, digamos que en acorde con la tendencia normal, entonces es de integridad todavía mayor. Finalmente, entonces tenemos los resultados, donde vendrían siendo pues nuestro mapita, Tenemos 6 imágenes, donde en cada una de estas imágenes tenemos uno de los factores de integridad, y al lado izquierdo, mi derecho, entonces la integridad total. ¿Qué es importante ver acá? Vamos a ver que cada uno de los factores tiene un patrón espacial diferente. Hay algunos lugares donde vamos a tener que varios factores actúan en un mismo sitio, que al finalmente pues se va a reflejar en una integridad total, pero es muy interesante ver cómo cada uno de los factores, cuando los vemos por separado, pues va a tener un patrón particular. Por ejemplo, el de conectividad, se van a dar cuenta que en el conectividad tenemos una baja conectividad en una parte particular, eso viene siendo la cuenca alta del río Meta, porque hay una relación de que en esa zona particular pues hay embalses y represas, y eso está causando pues un decremento en la conectividad longitudinal. Tenemos la parte perdón, ahí quedó régimen hidrológico, pero es el de variabilidad climática. Entonces tenemos que hay unas zonas tanto en la parte que está cercana a la cordillera, en la parte alta como en el piedemonte, y también sabana inundable, que, ay, me equivoco siempre, que viene siendo como esta zona, donde también pues hay cambios en los valores de integridad. Entonces es muy importante pues ver la figura tanto completa como por partes para saber exactamente qué es lo que hay que hacer y dónde. Y finalmente, si vemos ahora, sí, estamos viendo el de integridad total. Este es un mapa donde podemos ver la integridad total y cómo se sobrelapa entonces unas áreas protegidas y de manejo especial. Aquí vamos a ver lo que son los parques naturales, las OMEC, las reservas campesinas, los resguardos indígenas, y al hacer esto y sacar números, entonces podemos ver una tabla como la que están viendo acá, donde pues tenemos para cada uno de nuestras áreas, tenemos los índices de integridad correspondientes y la integridad total. Para el caso de los resguardos indígenas, que es el que estoy mostrando, pueden ver que es el que tiene mayores valores de integridad, mientras que las reservas campesinas son aquellas que tienen menores valores de integridad total, como en cada uno de los componentes. Pues toca tener en cuenta que son las reservas campesinas, pues de todas formas son unas figuras que están hechos para el desarrollo sostenible, no es para la conservación, entonces pues toca entender también por qué tenemos valores más bajos en este tipo de áreas de protección. También tenemos lo que acá escribo como RUNAP, me refiero a diferentes formas de parques naturales, entonces también tenemos valores bastante altos. 0,89, me voy a quedar acá con tortícolis. No sé si pudieron traducir eso. Lo siento. Entonces tenemos valores altos y básicamente me está mostrando pues la importancia de este tipo de áreas para la conservación de los diferentes sitios. Y finalmente la última tenemos la SOMEC, que está en la última fila, que pues es una figura de todas formas, pues no tiene valores tan altos, pero toca tener en cuenta que es una figura relativamente reciente y es muy importante de todas formas, tanto en esta como en todas, hacerles un seguimiento para saber exactamente qué está pasando, qué podemos actuar, qué tan efectiva está siendo. Como conclusión, entonces tenemos que la integridad es un indicador efectivo y es compuesto y que es muy importante verlo por sus partes, porque esto nos permite interpretar correctamente esas afecciones, los patrones, dónde, cómo y cuándo, qué hacer. También vemos que al momento de ver esto en las diferentes áreas protegidas o en diferentes estrategias de manejo, pues nos permite precisamente hacerle un monitoreo y seguimiento, celebrar o hacer las correcciones pertinentes. Y finalmente, ay, me comí algo. Para su uso nacional, entonces, que son cosas muy buenas. Primero, que tenemos muchísima información que nos permite hacer este tipo de cálculos, que a pesar de que vengan en diferentes resoluciones, tanto temporales como espaciales, se logran y se dejan integral para hacerlo. Y hay algo, necesitamos una red hídrica que sea continua y consistente en todo el país. Para este caso del ejercicio de la Orinoquía, pues el ejercicio se hizo a partir de una red que se derivó directamente del modelo de elevación digital. ¿Por qué? Porque si bien el país tiene una muy buena cartografía en cuanto a ríos, tenemos desde la parte nacional, 2 tipos de geometría, líneas y también tenemos polígonos, y no es una red conectada. Y esto pues no permite que entre directamente a los análisis de los modelos hidrológicos, y por eso necesitamos encontrar una forma de tener pues esa red completa para poderlo aplicar a nivel nacional. Bueno, muchísimas gracias.
Muchas gracias. ¿Alguien tiene un comentario, una pregunta? No. Gracias. No me acuerdo el nombre. Ok. Acabó el tiempo, ¿no?
That concludes our talks. We do have a few minutes left if anybody wanted to ask any questions of our presenters.
For you, para usted, yo voy a hablar en colombiano, pero que se tu não entendeu, eu hablo em português e someone translate for you. And tu índices is tu índice em espanhol, ok. Tu índices, você vai usar estes índices para tomada de decisão, como, por exemplo, decidir sobre o local de uma hidrelétrica, de uma mineração. Eu fiquei um pouquinho em dudas, porque tienes uma informação a respeito de pluviosidade que impacta no índice, certo? And as outras características, eu não vou conseguir direito.
Sim, eu entendo.
Está entendendo? As outras características são características do local, pero que quando tu usas pluviosidade como uma característica, esta característica pode influir negativamente em a região. Eventualmente, this unidade de planejamento, né, que você está usando, pode ser degradada, pero que não é um problema de ela, é um problema de mudanças globais. Tu entendes mi ponto? Então, pode dizer que uma área não tem mais tanta integridade, pode botar alguma coisa como uma mineração, mas o problema não está nela, o problema está na situação de mudanças globais e está trazendo uma precipitação maior para aquela região ou mais instabilidade para aquela região em relação a esse parâmetro.
La agarré. Bueno, creo que fueron como 2 preguntas en cierta forma. Respecto a lo último, el uso de la precipitación, sí, efectivamente, pues no es algo que sea directamente como una presión antrópica, más sin embargo, sí repercute en la integridad de los ecosistemas. Entonces, no es como, ¿qué puedo hacer respecto a cómo cambiar eso? No, pero sí tengo que tener en cuenta que ese factor me está afectando de todas formas la integridad de lo que de pronto antes llovía mucho, entonces simplemente se me va a transformar, entonces algo que de todas formas, independientemente de que no sea algo que nosotros podamos directamente, no podemos controlar, de todas formas es algo que está afectando y que se tiene que tener en cuenta ahí. ¿Y por qué? Porque además, si se obvia, pues también le puedo empezar a echar la culpa a todo eso, pero después, no, era eso. Entonces, es precisamente por eso que es muy importante incluirlo, porque es un factor que está afectando y que si solamente tomamos lo antrópico, pues no vamos a saber exactamente qué es lo que está pasando. Y respecto al uso, creo que esa era como otra, ¿o no?
Respecto ao uso da tomada de decisão sobre o que você irá fazer com este pedaço de terra.
Con un pedacito de tierra.
Com esta unidade de planejamento, com este espaço.
Bueno, en cuanto al uso de la integridad, pues tiene muchas aplicaciones. Por un lado, lo que le mencionaba, se puede hacer un seguimiento a lo que se está planeando, a las estrategias que hace el país, entonces se hace un seguimiento para saber su efectividad. Por otro lado, hubo una charla, de hecho, lástima fue antes que yo, donde explicamos precisamente cómo estamos usando este índice, para priorizar áreas, crear portafolios para la priorización de ciertas áreas que cumplan con condiciones para características y donde se definan unos porcentajes 30-30, 34 de acuerdo al país. Entonces, pues también, por ejemplo, ahí hicimos un ejemplo de la aplicabilidad del índice. Y de ahí para abajo, pues es que es muy amplio lo que se puede hacer. Monitorear es chévere.
Gracias. Thank you. Thank you, Rodrigo. Last question. One online as well. Sorry. So we have a question. I'm not sure to who. Silas from. Policy decisions often require urgent data, and we have to work with what's available. This session showed that we can still produce valuable insights despite existing data gaps. But how can we remain transparent about these limitations while also drawing government's attention to the need for stronger support and funding for data collection and management? It's a question I'm not sure for.
I think that question is for everybody here in the room. Do we want to take the other question from the room?
Thank you. My question is for Gabriel. I'm sorry if you present, but I missed that. But it's not clear for me how you decide if a matrix, a network matrix, fits the criteria. So you have objective information and any others. They have a set of rules that the matrix must fit. So you decide, or is a argumentative approach? How you decide that?
Yeah, well, thank you for your question. Well, to answer, I wouldn't say that it's necessarily a set of rules that we have. Maybe that part is more on the measure by measure, but what I wanted to highlight was more that we need to do this process of thinking, and those are arguments that we can give to practitioners and decision makers that help sell the measure and might facilitate the uptake. So in what I presented, there's no rules that are already defined. It would be a good thing if we had some, of course, but I think I wanted more to highlight the process, that it's important to just think about them and try to fill these in by ourselves, and to present that point.
Thank you, everybody. I think that concludes our session. Sure, for sure.
Thank you. It's very fast because I'm here and everyone here hear about if you don't have information, we need to take some decision with information that we have. But we deal with the situation in Brazil for a long time, and so in 2007, I think, was created the planning of a protected area over there, and the prioritizing of protected area over there, and the mainly places that you need to protect was close to the center of cities, Manaus, Belém, because of course the bias of the effort. And we can use this data, any data of the sampling. So we use the data of raster and satellite images. And I see some presentations here, and I think this is a huge problem. And I just could take some note that eventually we can use the information for take decisions. We need looking for another decision or another information, because our information, mainly that or from a sampling field, could be so degraded, so scarce that you can't just use it because you make a wrong decision.
Thank you.
Another comment to Sila's question online is like we know that in Brazil there's lots of research projects, some calls for more research. We should, all of these calls or like projects, we should add this data must be available when your publication is ready, or when you publish your scientific article. You should publish at the national level, and then you can get the data online, and then you share it through GBIF or through OBIS. And this is a practice that we don't really do in Brazil, is my opinion. So
we've gone quite over time, but thanks for the good discussion. Does anyone have anything else that they'd like to share? Anything online? No? Well, thank you very much, everybody. Oh, if all the presenters want to come up and have a photo, that would be great.